Namaste, welcome to Sarat Chandra IAS Academy. So, as you know, the Nobel Prizes have been announced recently. So, today we'll talk about the Nobel Prize in Chemistry. So, this year the Nobel Prize has been awarded to 3 people. So, these 3 people have shared a Nobel Prize. The first half of the Nobel Prize goes to Dr. David Becker. So, the David Becker has played a very important role in the synthesis of new proteins which are not existing in nature. So, he has been awarded the Nobel Prize for computational protein design. So, this computational protein design essentially means that they have designed a new protein using the computer methods. So, in nature we find a number of proteins which are a result of evolution, but Dr. David Becker synthesized new protein structures which are not available in the nature. So, these are designed in the lab, but this has various applications which we will discuss in the due course of time. Now, the second half of the Nobel Prize went to these 2 people. One is Demis, Hassabis and John M. Jumper. So, this Mr. Jumper and Hassabis have played a very important role using the artificial intelligence. So, this artificial intelligence is also becoming a very important theme in the UPSC in the coming years. Now, we need to pay focus about how this technology has enabled the discovery, and the Nobel Prize has been awarded for what purpose. So, what they have done is they have synthesized a new AI software called as, so this AI software is called as AlphaFold. So, the job of this AlphaFold software is to understand that how proteins are folded and unfolded. So, the protein folding and unfolding process has been understood through their work of protein structure prediction. So, we will see in detail. For prelims perspective, this much is enough, that what is protein folding and unfolding and what is computational protein design. So, in case of computational protein design, what we do? We will synthesize the proteins which are not there in the nature. So, nature lo leni kotta proteins ni create chestam. So, that is one thing. And the second half of the prize goes to these people who have understood the existing proteins. So, already the proteins which are existing in nature, we have understood what is their 3D structure. So, they have understood 3D structure using a software called as AlphaFold. So, this may come in prelims asking about what is AlphaFold related to. Now, let's see a detailed explanation for mains perspective. Now, first let us see about the existing protein structure. So, this is done by the work of Dr. Hassabis and Jumper. So, what they have done is they have used a software called as AlphaFold 2. So, these people are, he is the founder of DeepMind, which is a subsidiary of Google. So, what they have done is they have used machine learning and pattern analysis to understand how the protein structure work. So, earlier the method used to be X-ray crystallography. So, to understand how a protein works, you have to do the X-ray of the protein. So, when you do X-ray of the protein, that usually reveals the structure of the protein. So, how the protein is construed, that is revealed through X-ray crystallography. But the problem is, it is very time taking, very expensive, and we can only do for a limited number. So, they wanted to overcome this through the machine learning. So, because of which they have conceptualized a 4-step method. First one is training of the algorithm. So, they feed all the data into the AlphaFold software. So, when you feed all the existing databases into the AlphaFold software and you train your machine on that. So, this is the first step. In the second step, what they have done is, so this is a structure of protein. As of now, we have discovered 20 amino acids. So, these are called as base amino acids. So, using these 20 amino acids in a series of combinations and permutations, so we get all of the existing protein structures. So these 20 amino acids constitute the hundreds of thousands of proteins that we have. Now, in the first step, they have trained the algorithm using data. The second step, they are trying to do a sequence analysis. So in case of sequence analysis, they will list down all the amino acids. So these are the amino acids in different animals, and they'll see if there is a pattern. So if you observe there is a pattern between these four, so that means all of them might have evolved together. So all of them can have a common ancestor, all of them can be originating from a same gene pool. So this is their hint to understand that. So by this logic, if you are able to understand structure of this one protein, you can be able to understand the structure of these proteins also, because all of them have a similar structure. So that is their second step. In the third step, what they did was, through AI, using artificial intelligence, through the neural networks. So this neural networks has become a very buzzword due to the ChatGPT. Now if you observe, the Nobel Prize in Physics is also given for the use of neural networks, which we'll discuss in the next class. So through the use of artificial intelligence, now they're able to predict the shape of the proteins. So these are all the proteins that have been discovered using the AlphaFold software. So AlphaFold software has been a key ingredient in understanding the structure of these softwares. So now what happens? Now there is no need of X-ray crystallography. So X-ray crystallography has become an old and obsolete technique. Now through the machine learning, through pattern prediction, we are able to understand the 3D folding of the complex softwares which used to take years earlier, now within a few minutes. So this is the importance of their work. Now Dr. David Becker, what he did was, he went a step further than the AlphaFold. So AlphaFold, what is it doing? AlphaFold is giving at the structure of the existing proteins. Now Dr. Becker thought, when you input the list of the amino acids, it is predicting the structure. So he thought, what will happen if you do in the reverse? So he invented another software called as Rosetta. So if you remember, Rosetta is an ancient Egyptian stone used for translation. So here also he have used it in a reverse way, that he has given a protein structure and he wanted to understand how the amino acids can be folded to achieve such a structure. So through this, he have achieved this new protein which is called as top 7. So this top 7 is a new protein which is not found anywhere in the nature. It is a completely artificial protein. Now, due to synthesis of artificial protein, there are numerous advantages. So the most important advantage is medicine development. In case of medicine, we can develop custom medicines which are not there in the nature. For example, in the current era, what happens is, we depend on the nature for protein. For example, penicillin is a derivative of a bacterium. Now, if we have custom proteins which are not a derivative of any other organism, we can design as per our own needs. So the work of David Becker is significant because it enabled the creation of new proteins. So this Nobel Prize is an acknowledgement of the work of unfolding and folding of the existing proteins and the creation and the path of creation of the new proteins. So this year, we can say the Chemistry Nobel Prize has been given to understanding the role of protein and its role in the development of human evolution. Thank you.